Okay, so in this clip we will look at the state pattern. Okay, again, you guys should go ahead and look at the state pattern here from Wikipedia. Okay, so you should read it a little bit and then go to this website. I would provide the links and the source code in the wiki link of the course. Okay, so before we continue, you should go and read this description of the state pattern. Okay, so you can pause the video and go ahead and read this. Okay, so the idea is that when you implement a game, your object may have complex states, and to implement a state, usually you end up having to a really big switch statement to look at the states and do a bunch of stuff. But if you encapsulate the behavior of each state of an object as an object itself, and allows the state to do the handling of the behavior on that state, and also the states change, then you can decompose a bunch of behavior on different state into different class, and now you have a much cleaner code. Okay, so let's look at our example code for that. Okay, so this is a simple game. So you have a green dot, and if you press the keyboard, it moves horizontally, and if you press the keyboard again, it moves vertically, like that. Okay, so that's a simple behavior. Now we would like to implement a state, like when you hit the red dot, you should the green dot should have an increased speed for quite some time, and then the speed would go back to normal, and the red guy would move to the other random point. Okay, so let's look at the current code that we have. Okay, so I have two dots. So the red dot only have one method called random position. So if you hit the red dot, then the red dot should move to the random position. And the other thing is the dot class. So the dot class would just move. Okay, it goes there's a speed thing, and it also, so it has a state called direction, for which initially it's an up direction. And when we change, we have this array called DAR offsets that would basically maps between the direction and the change in the location of the dot. Like if you have a DAR up, you would increase the x coordinate would remain the same, but the y coordinate would decrease. If you go for the right direction, the x coordinate would be increased by 1 or by some unit, and the y coordinate will remain the same. So with this map, the offset map, you can pretty easily implement the movement of the dot. Okay, and when you hit the keyboard, so here I do a simple thing. If you hit the keyboard, you change from up to right, and you can change from right to up after you hit the keyboard. So you can fix this later on if you want to make it 4 direction the way you like. Okay, so that's, and I also have the wrap position. When you reach the boundary of the game on the left and on the right, you just go to the other direction, the other side of the game boundary. Okay, so now let's do the simple thing first. If you hit the red dot, then the red dot should random position. So that's easy. So if self dot is close, is too close to. So let's copy that. So previous code, right? Okay, so I'm gonna copy from the previous project. It's too close. So that's the code. So not gonna be too close, it's close. So if close to maybe 5 points, then I would just say it's close. Okay, just hit that. So if it's close, if dot is close to, let's say, to red dot, then let's reset dot random position. So let's see if it works. Oh, math is not defined. Import math. Okay. Oh. Oh. So 2 is too close. That's pretty hard. Okay. It's really hard to hit. So let's change this to maybe 10. Okay. Oh, that's okay. You can hit it, okay, but you need to be really close. Okay. All right. So now, okay, so let's implement the state for now. Okay. So if it hits the dot, so I would, so let's do it without the state pattern. Okay. So the dot should have the self dot excited equals false. So if it hit the red dot, it would call it change to excited. Okay. So if self dot excited, we do some things. Else we do the basic update. Okay, so if I'm excited, I would move like 3 times faster. Let's do that. Okay. And let's see if it works for now. I need to hit this guy. Right. Oh, that's hard. You learn how to test your code later on. Oh, okay. I hit it, but doesn't go faster. Oh, I haven't. So if it closed, then I say self dot excited equals true. Okay, so let's run it. Oh, okay, so it's getting fast, but I need to stop moving fast at some point, right? Otherwise it would be really hard to hit the other guy again. So I need to maintain the counter. Okay, so let's say so I need cell excited counter to be 0. So let's call function excite get excited. So let's say cell excited equals true, cell dot excited counter equals 0. So if I'm got excited, then I would say counter add to 1 if 100, then just get excited for 100 steps. So save that excited equal to false. So let's do that. And if I'm too close, then I get excited. Okay, excited. Okay, so let's run it. I need to hit the guy. That's hard. You learn how to test this thing later on. Okay, if you when you want to test a thing, you need to play it every time. It will take years to implement the game. Okay, like this. Okay, I'm get excited, and then okay, it stopped. Okay, it's come back to the slow speed. Okay, so let's hit it. Okay, it's getting slow now. All right, but if you have more state than that, then it will get really bad. I mean the code for this update method will get much worse. Okay, so we'll try to apply the state pattern here. Okay, so let's create a class called dot normal state, and then class dot excited state. Okay, so these two state will do the update on the dot. Okay, so I would call dot state. So the initialization would be just that. I'm not gonna have it. Let's do it this way. Okay, and then update state. Okay, so let's call dot so let's do the update. Okay, so if you are in a basic state, then you call this and call wrap position. Just that. So this is like a simple state. But if you are in dot excited states, then you should have this 3 times. Okay, and then you also need to have a counter, so maybe 0, and after you update, you increase the counter 100, then you do something. And equals 1. So if the counter is 100, then you change the save dot. No, not this is not xy. This should be save dot x. So let's say dot equals save dot x. You can encapsulate this as a function, but let me try to read it in a really bare bone way so that you see the actual logic behind this. Okay, and then I would maintain a counter, and if the counter is 100, then I say self.state equals dot normal state with the dot itself. Okay, so I change the state back to normal. Okay, so the dot itself, the excited is gone, so that I say dot state equals dot normal state, and my got excited is like then self dot state equal dot excited state, and on my update I just throw everything away, and then it say self dot state dot update, and then that's it. Okay, let's see. Oh, why do I move backward? Oh, okay, so okay, dot y, sorry. Okay, so let's run it again. Okay, now I move really fast, and then okay, I stop moving fast. Okay, I move fast after 10 steps, after a few 100 steps. I move slow now. Okay. You can see that we have encapsulate all the, so we have these two states. Okay, it describes the behavior of the dot when they are at different states. Okay, and the dot itself would maintain the state, and when we do the update, just call the state.update. And if we have a more complex state transition between dots, like say after 100 steps it moves to a really slow dot, we can implement it as another state and pass it to the dot. So we implement the state machine using the state object. Okay, so that's how you would apply the state pattern. Okay, so the last state the last pattern that we would look at today is the singleton. Okay, the singleton pattern is you're gonna use it when you want to have a single instance of a class. So so you don't want to create a lot of objects of a particular class, because you just need only one of them. Okay, so you do that because you want to save the memory. That's the first reason you want to use it. Another is when you really need like on a system there should be one controller of something, because your machine has only one of that. Like for example, if you have a screen, then a single application maybe can only have exactly one screen or one keyboard or one particular object that your program should have only one of them. Okay, the way to ensure that you only have one instance of that class is to use this singleton pattern. Again, as I told you, you should go ahead and read the pattern here. Singleton pattern before you continue. Okay, and here as well, singleton. Okay, so you should read both of that, but you can see that the singleton pattern is the original one of the original gang of four pattern, but it is currently considered to be some pattern that you should avoid using it. Okay, also in this book as well, it doesn't it tells you that you should not use this. Okay, so if you are inclined to use the singleton pattern, think about it twice. If you still want to use it, think about it twice again. Okay, you have to be really sure to use the singleton pattern, because most of the time you can get away without using this pattern. And furthermore, using this pattern, singleton pattern, may create some crazy thing that you don't want later on. Okay, so basically this pattern would do something like this, to prevent yourself from creating two, like say, suppose you want only one red dot here. Okay, this is just an example. Okay, so you would do something like this. So you would create a static method called get instance, and then it would create a red dot. Okay, it would create a red dot for you. Okay, so let's say this is how you create a red dot, right? A red dot. So, but you want to keep the red dot here. Okay. So red dot instance equal red dot, and then just return like that. Okay, but you need to check if you already have the instance or not. So if not red dot instance, so you create it, otherwise, and then you just return the instance. So to get a red dot, you call red dot get instance. So this is how you call it. So let's run. Oh, red dot oh, get instance. So you need to pass the app to it, right? So get instance app. Okay, that's the red dot. But if you want to get another red dot, it will be the same red dot. So let's say when you hit the red dot, so you want another red dot. So let's say red dot get instant with the app again, and then random position. You can see that the same dot move, right? Because when you call getting the red dot here, so you get the same instant of the red dot. So if I just throw it away here, if I don't check that, if I always create a new red dot, then you can see that our code would have a bug here. Although I hit it. Oh no, I need to hit it. See, this is another red dot over there, right? So if I hit it again, where is the red dot? Yeah, I don't know where it is. It should be somewhere. But anyway, so I need to, then you see two red dots over there, right? But if I just call this red dot, I would check if I would have this just a single red dot over there. So yeah, it moved. Okay, but if I create, now this is half of the singleton pattern, then you need to prevent the user from directly create the red dot instance. So typically you would override the init method cell stuff to somehow disallow you to create another instance. Okay, but anyway, the singleton pattern is convenient. Okay, when you want to make sure that you only have one instance, you just get the instance from the class. Okay, but it means that when you want to have an instance of this, you always have to, you know, create it from the class method. Okay, so you cannot have a dummy class for this, because you always have the way you're going to use this, the object of this kind is through the class itself. So you would create the coupling between the class name and this object instance. Okay, and later on when we learn about when you learn about unit testing, you will find that it's really hard to test this kind of object. And any class that use the singleton, any class that use an object that use the singleton pattern, you cannot mock it. You cannot have a fake object of this kind, because the only way to get an object of this kind is through the class itself. So it's really hard to test. It creates dependency on the class, and you can't even inherit the object from this class. So this is why you should at all costs avoid using this singleton patterns. Okay, so this is one example of a pattern that is very, people find that it is very useful in the beginning, right? But after the culture or the technique or the technology or the belief change, this pattern becomes kind of obsolete, and it becomes what people refer to as anti-pattern. So anti-pattern is the pattern that you shouldn't use. Okay, so a singleton, you should avoid using it, okay, at all costs. All right, so to conclude for the lecture for this week, why would you want to learn design patterns? Two reasons. One, they are very useful for your design, and two, by seeing good designs, so design pattern is usually, they are usually beautiful, right? When you look at many designs products, you see how the designer balance the trade-off between various requirements. This is true for object-oriented design as well. You want to do something, and you want to make sure that it's easy to change. It hides the unnecessary details. It allows you to adjust, and it gives you flexibilities. Your code will look nice. From these design patterns, you see most of that. So you would in turn learn the object-oriented design while you learn the design patterns. So that's the byproduct of learning the design patterns. All right, so that's it. I'll see you in the lab sections. We're gonna have a bunch of codes that I will let you try to apply a few design patterns to the code so that it looks nicer, or you can implement some nice functionality. All right, see you then. Bye.